Caching is something you can set up straight away at the start of your project. It solves a problem that a lot of people have where you're trying to fetch data from your database and you're making repeated calls to get the same data. You can have a caching layer which gets the data to you faster because it has it in memory. Most of the time people will go get, no pun intended, a library to use instead. But let me show you how easy it is to implement your own caching package. Let me preface this by saying this isn't the most robust implementation, but it's a good place to get started. It's an easy in-memory cache, which you can easily switch over to Redis if you need to use it in the future. Here's the cache Go package. I've written down a simple in-memory cache until I need Redis or something else. Hopefully it's very easy to understand. So what I have is a typed cache entry. This is what the entry of the cache expects. So usually it'll have a value, a created at, and a TTL, a time to live. So this is like, no matter what happens, as soon as the time's passed, delete the cached value. Then I have the memory cache struct, which has the cache entry, which is a map string to cache entry, and a sync mutex. So the cache implements a interface called cache. It has a set method with a key string, a value byte, which is the value itself, and a time to live. I've set a default time to live to 100 seconds. It's got a delete method, which removes the key value from the cache, and it's got a get method, which essentially gets the data based off the key. So when I have a Redis cache, I can create a Redis cache struct, and all it needs to do is implement this set delete get method, and it'll work everywhere in the project. Let's look at the methods. I instantiate the memory cache with a new cache, and so I create the cache with no entries and a sync mutex. I set up a ticker, so every 100 seconds it will loop, so it'll go through the cache and then delete whatever time to live has passed. And then a ticker stop when context is done. This is when I've killed the program, it just stops. And then I return the memory cache. Let's start off with get. Because I don't want any race conditions, I use sync mutex to lock and unlock the function. So the way it works is it starts off by locking the get and then deferring the unlock. And then what I do is get the cache based on the key. If it doesn't exist, I return a nil value and false. And if it does exist, I return the byte array and true. Pretty straightforward. Then we have the set, which is a little more complex. I pass in the key, value, and the time to live. If no time to live value is set, for example 0, I set the default to 100. Then I set the time to now, and then I set the value, which is a byte array, the time that it is now, and how long it needs to live for. The reason I have a time to live and not consistently update whenever the cache gets updated is because if the data does ever go out of sync, I want it cleared no matter what. And then one data fetch every like 100 seconds isn't too bad. And that is why I have a time to live. Then we have the delete, which just deletes from the cache. It's really straightforward. Then we have the reap loop, which, like I said before, it needs to run whenever the ticker ticks, which is 100 seconds. So what happens is it checks the time value since the cache value was created at, and then checks if that's greater than the time to live. If it is, it deletes it from the cache. Let's see where it's actually used in the program. So let me go into main.go. Here I implement the cache and I pass it into my services. Let's start with activity service, which is probably the easiest one to show. The way this works is, not sure why there's a delete in the create one. This might be a bug. I'll look into this later. Okay, this makes sense. So when an update happens, I need to delete what's in the cache because I've got new data. And this, I'm guessing it should be a get rather than a delete. Okay, that's a bug. I'll leave that for later. So list returns a list of activities. Cache keys usually has the service name at the start, and generally it has the org ID, but other times it'll have the ID of the data that it's trying to get. So this is how it works. I start off with a get using the key to see whether the data exists. If it does exist, I unmarshal the data and I have a logger just to say that the cache hit, and then return data and nil. This is straightforward. This is just getting the data, hitting the database when cache is missed, and then I marshal the data, I set the key 50 seconds, and then I return the actual list of activities. Very straightforward. Okay, I see why. I see why I have create, delete, cache. Because in the list, I list all the cache data. When I create a new one, the old cache, the cached list is outdated. So what I actually need to do is delete it, and the next time it fetches list, it returns all the data, including this new created activity, which is why I delete the actual cache for list. I should probably do activity list, so it makes more sense, but yeah. And then we have delete. When the delete occurs, I need to delete whatever's in the cache, and if I do delete all, I also need to delete whatever keys in the cache. And then the way this would work is in the rest of the application, rather than calling the database queries directly, it calls the service functions. So it'll create using the activity service create and activity service update instead of db query create activity log. This way it will delete the cache when it has to and update the cache when it has to, because when it calls the database directly, it ends up affecting the cache because the cached value and the actual value would go out of sync. This is like the correct implementation. One thing I've forgotten to say is that when I create a service, I pass the cache interface instead of the memory cache. This way, when I switch this to Redis cache, I can just switch out the cache new cache to new Redis cache and just swap that out. And it's that straightforward instead of going everywhere and replacing memory cache, memory cache, memory cache. That's how I've implemented my caching. At some point, I'll implement Redis cache. At the moment, I don't need to because the application's hosted on a virtual machine, so I'm using the RAM from the virtual machine. But in the future, when I go to like service-based pods or like containers, I will have to switch that to Redis. That's my cache implementation. That's all there is. And that's everything for today, I guess. Bye.